All right, today we're going to go on a little journey. We're going to follow just one single line of code, from the moment it's an idea in a developer's head all the way to a live production environment running on Azure. And along the way, we'll uncover the secure, multi-stage pipeline that actually makes it all possible.
So this is really the big question, isn't it? How does one line of code get from a developer's laptop safely all the way to potentially millions of users? It sounds so simple, but that journey is actually packed with automated trials, critical checkpoints, and, essential human oversight. So let's think of this as the story of our hero, a single code change on its epic quest to reach production.
And here's our map for the journey. Our code's adventure has 4 really distinct stages. We're going to start in development, then move through testing, face a super important approval gate, and then, finally, we arrive in production. This very structure is the key to balancing both speed and safety. Every great journey has to start somewhere. For a little piece of code, that's what we'll call the call to adventure. That exact moment a developer commits a new feature or a bug fix. That simple git push command, that's what kicks this whole automated pipeline into gear. The adventure has officially begun.
Okay, so as soon as that code is pushed, it enters the pipeline and immediately faces its first set of automated trials. This all happens in the development environment, which kind of acts as the initial proving ground. It's right here that we catch the most obvious issues, and we catch them fast.
So this is the first gauntlet our code has to get through. First, it gets compiled or built just to make sure all the syntax is correct. Then automated unit tests kick in. These check individual little pieces in total isolation, like making sure one specific function calculates a total correctly, completely separate from anything else. And finally, static analysis tools scan the code for common bugs or security holes. It's just a rapid-fire series of checks.
So why do all this right up front? Well, it all comes down to this core principle. Fail fast, fail cheap. I mean, think about it. Finding a bug here, just minutes after a developer commits it, costs almost nothing to fix. But finding that same bug a week later in production? That could mean your website crashes during a holiday sale, costing you thousands or even millions in downtime, and maybe worse, lost customer trust.
So, our heroic code change has passed its initial trials. Now it gets to advance to a much more rigorous stage, the test environment. This is the advanced proving ground, and it's designed to mimic the real world as closely as we possibly can.
Here, we're not just testing code in a vacuum anymore. It's actually deployed to a real environment, something like Azure App Service or a Kubernetes cluster. That's AKS, by the way, a system for managing big applications. Then we run integration tests to see how our new code plays with other services and databases. We hit it with performance tests to make sure it's fast and can handle a real load. And for the first time, a human, a quality assurance engineer, might get involved to do some manual validation. Now, you might be wondering, how does the exact same code work in all these different environments? And that is a crucial point. We use features like variable groups in tools like Azure DevOps or GitHub Actions, and these let us inject environment-specific settings. The code itself never changes, but it knows to connect to the dev database in dev, the test database in test, and in production, it securely pulls its secrets from a service like Azure Key Vault. Pretty cool, right? Okay, so our code has passed every single automated test we've thrown at it. It's proven to be stable, functional, and performant. But technology alone is not enough. Now it has to face the gatekeeper, that critical human element of our pipeline.
You can almost feel the tension, can't you? Everything's looking green. All the automatic checks have passed. The code is sitting right on the edge of production, just waiting to be deployed to millions of users. But there's one final, mandatory pause. And this is that moment. The pipeline actually halts and sends out a notification. A team lead, maybe a security officer, or a product owner steps in. Now, this isn't a failure, not at all. It's a deliberate design checkpoint to make sure everything is aligned from a business and security perspective before we make that final leap.
This checkpoint actually has a name. It's called a gated promotion. This is way more than just a step. It's a deliberate architectural pattern. It's a formal process where a person reviews all the evidence from the automated stages and gives an explicit sign-off. This gate is really the ultimate safeguard against a feature that might be technically perfect, but just isn't quite ready for prime time.
So what does that approver actually check? Well, they're running through a kind of pre-flight checklist. They look at all the automated test results, they verify the security scans came back clean, they make sure the QA team has given its blessing, and sometimes they even get approval from a business stakeholder to ensure the feature is ready from a market perspective. And approval granted. The final gate swings open. With that sign-off secured, our line of code is finally cleared to complete its long journey. It is now automatically and safely deployed into the live production environment. It made it!
Now, its arrival isn't just one single event. First, the code gets deployed. Immediately after, a small set of smoke tests run. These are just quick checks to make sure the most critical functions, like logging in or adding something to a cart, are working. And from that second forward, monitoring tools like Azure Monitor are watching its health, its performance, and its error rates like a hawk.
So our code's journey is complete, but the story isn't quite over. The pipeline itself is a piece of living software, and it needs to be maintained. So let's talk about some best practices to make sure this whole system works for the next 100 or even 1,000 code changes.
Here are some key takeaways for building pipelines that really last. First, define your stages in reusable templates so you're not just copying and pasting code everywhere. If you have complex logic, put it in a separate script instead of cluttering up your YAML file, which is the language for these pipelines. Like we saw, use variable groups for all your configurations. And finally, document everything so the next person who comes along understands why the gates are where they are.
And that really brings us to our final thought. A great pipeline solves the problems you have today, but an exceptional one is built to adapt. So as you think about your own systems, ask yourself this: how is this architecture going to evolve? Will you add more automated quality gates? New security checks? A pipeline, just like the code it deploys, is never truly finished.